At today is two different specific types of triangles. We're looking at isosceles triangles and we're looking at equilateral triangles. So we mentioned earlier in this unit that isosceles triangles are triangles that have two congruent sides, whereas equilateral triangles are triangles with all sides congruent. So in terms of some vocabulary, first off, the legs of an isosceles triangle, these are the ones that are going to be congruent. So if you think about us as human beings, if we were to stand with our legs, our feet shoulder width apart, our legs hopefully are going to be the same length, or in some cases close to. But in an isosceles triangle, they are the ones that are the exact same length. In terms of the vertex angle and the base angles, we're going to talk about those last. The next thing that I want to talk about, though, is your base. Base does not mean bottom. Base is the side that is not the congruent side. So you locate your legs first, and then the side that is not congruent to the other ones is considered your base. Your base can be on the bottom, it can be on the left, it can be on the right, it can be on the top, it can be anywhere. So just remember, base does not mean bottom. Now, when we talk about base angles are just the angles that are up against the base. So we have this angle is a base angle, and then you also have this angle here is considered a base angle. That leaves the only other angle here is considered your vertex angle. And so your vertex angle is the angle that's formed by your two congruent sides or formed by the legs. Another way to look at it is your vertex angle is directly across the triangle from your base. So again, legs of an isosceles triangle, they are the congruent sides. Base is the other side. Base angles are connected to the base. And then your vertex angle is the angle formed by the two legs. Okay? So that's just some quick vocab that we can use as we're referencing these triangles. The key for today, though, is what are the relationships as far as congruencies? So what I mean by that is this. If you look at the very first theorem, it says if two sides of a triangle are congruent. So first off, we have these two sides are congruent. If those two sides are congruent, then the angles opposite. So if you're standing at that side and you're looking across the triangle, we're looking at this angle. And if we look across, we are looking at this angle. So those two angles will also be congruent. Okay, the second piece, that converse, we've seen that word converse before, that just means the flip. So in the first one, we know the sides are congruent, so we can make conclusions about your angles. Whereas for this one, we know our angles are congruent, so that's going to allow us to say that this side across from angle E and this side across from angle F are going to be congruent. And that's where you see the segment DE is congruent to segment DF. Okay, so again, once you have the sides that are the same, the opposite angles will be the same, and then the flip is also true. If you have congruent angles, the sides opposite those will also be congruent. So if we look at number one here, we have two congruent sides. That means that the angles across, so angle D is across from this side, and then across from this side is angle F. That means those two angles are congruent. Now, some of you guys are quick to think that how to figure out this answer numerically. Others may want to use some sort of algebra. So we don't know this angle measure, but we do know that they're the same. So we would have those two labeled as x. So if you do it algebraically, you would do 2x plus 22. And we've already learned in this unit that angles add up to be 180 degrees. Now, some of you guys may recognize that what you would need to do is subtract 22 from 180, and that's going to give you those two at the same time, and then you would divide by 2. If you recognize that, that's the same thing as what this algebra solving is going to be. You're subtracting 22, so 180 minus 22 is going to give you 158, and that equals those two angles combined, so then I would need to divide that to get one of the angle measures. So when I divide, I get a value for the measure of angle F of 79 degrees. Okay, so again, you can either do it algebraically or you can do it logically, whatever makes the most sense to you. Now, if we look at the next one, we have this side is going to be marked congruent, so we're dealing with this angle that's across. This side is congruent, so we're going to be dealing with this angle that's across. So again, if our sides are congruent, our angles are also the same. So we would go ahead and we would set those two equal, and then we would solve. So we get 5x on this side, we get 40 on this side, so we get x equals 8 for a value. Notice it does ask us to find x, so we don't need to continue it by plugging anything in, but we could do so to check our work if we wanted. Okay, so take a second, read through this. Here we have a bunch of information in terms of just a word problem rather than a picture. So we have some information about this triangle. Again, if we have a word problem rather than a picture, my first suggestion would be to draw the picture. So we can draw it, and it doesn't matter how you draw it, and it doesn't even matter where your labels are in terms of your corners. But what does matter is once you go ahead and label that, we want to use this. That segment RT is congruent to segment ST. So if RT is congruent to ST, that means that this angles across from that, angle S, and across from here, angle R, those two angles are the angles that are going to be the same. So the way that we set up our equation, since we know R and S are the same, we can go ahead and just set those two equal to each other. And when I do so, I would subtract the 4x, or excuse me, subtract the 9x to get 4x. I would add my 18, so I get an x of 5, and I can go ahead and write that in. Notice it does ask you to find angle R, S, and T, so now we can just plug in. So 9 times 5 plus 2, which gives us 47. For S, we have 13 times 5 minus 18, and when I do that, I get 47. Now I'm going to pause right there. That should serve as the first check that we have two angles that are the same. We want that. It's isosceles. We need those two angles to be the same. The other check is when I go ahead and plug this in. For part T, so 17 times 5 plus 1, that gives us 86. Now, if I were to take and I were to add all three of those together, because we're talking about the angles of a triangle, those should equal 180, and they do. Okay? The difference for the next one is that you are looking at given angles that are congruent, and you're making conclusions about the sides. So again, we're going to do the same step to start. We're going to draw a picture. It doesn't matter where you put those letters, but it does matter what you label. Okay, we want to make sure that it's D and E that are congruent. And then from there, we can go ahead and label our congruent sides. So I'm going to pause this. I'm going to let you label your congruent sides and solve for X. And then we'll go from there and check to make sure that you guys are correct. Okay, so as we look at this, the side across is EF, the side across is DF. So if we're looking at EF and DF, we're looking at those two sides. Again, they are going to be congruent because they're across from angles that are congruent. And so when I set this up, I end up with 3x on the right. I'm going to add 35 to each side as well. And when I add 35 to each side, negative 8 plus 35 gives us 27. And when I divide, I get x equals 9. Okay, so I have 9 for that value. Again, we need to go ahead and substitute to go ahead and find our other side lengths. So if we're looking at DE, we get 9 plus 4, which is 13. If we look at EF, 4 times 9 minus 8, which gives us 28. And then 7 times 9 minus 35, and 7 times 9 minus 35 will give us that 28 again. Now, again, this serves as a check that we do have two that are the same. Notice for all of these, side lengths will be positive, angles will be positive. Angles will also check to be 180, but again, sides will not check to be 180. Okay, there is no special number that the sides of a triangle add up to be. So your only check for that second one is that you have two sides that are equal. All right, last thing here. If we look at this next slide, it says, using what we know about isosceles triangles, what can we conclude about equilateral triangles? Well, we know, based on the definition of equilateral, that we have sides that are congruent. Based on what we know about isosceles triangles, that if we have sides that are congruent, this angle is going to be the same as this angle, and then also as this angle. So not only are your sides congruent, but all angles will also be congruent. And specifically, all of those angle measures will be 60 degrees because all together they have to equal 180, and 180 divided by 3 is going to give you 60 for that angle measurement. So the only thing to be mindful of besides that is the terminology. Remember earlier on we put equiangular. Okay, so all equilateral triangles are also considered equiangular. As always, ask questions if you have them. Otherwise, that's it for today. Thanks.